Hello class. In this video we're going to look at multiplying mixed numbers by mixed numbers. But to begin with, we're going to do a review where we just multiply a mixed number times a whole number. So here's the problem I want us to focus on to begin with. And again, this is a mixed number times a single digit. And the way I want us to look at it today, I just want to draw a graphic organizer for us. Okay, so it's not proportional, we're just drawing these boxes to record our numbers in. And the reason that it is set up this way is because I have a single digit going down. Here's where I'm going to put the 5. And going across, I'm going to put the 2 plus 3/4. So I've taken this and I've divided it into two separate numbers. Okay, that can be added together to give me this total. So in doing that, now when I find the area of this piece and then the area of this piece, I can add those two pieces together and that would give me the total area or the answer to my problem. Okay, so in this piece, this first box, what I have is a box that is 5 by 2 and 5 times 2 is 10. And so in my graphic organizer, I'm going to put 10. Okay, that's the first area. And the thing that I need to remember, okay, and that some of us are struggling with is we're not just putting 3/4 down here, but we have 3/4 by 5. Okay, and 3/4 by 5, and that's 5 over 1. Okay, and that gives us an area of 15 over 4. So in this box here, I'm going to put 15/4. Now if I can add these two together, that will give me the total area of 2 3/4 by 5. Okay, now before I do that, I'm going to need to alter this one a little bit because I have an improper fraction. Okay, so I'm going to take my 15/4, divide 15 by 4. Okay, so 15 goes into, 4 goes into 15 3 times. 3 times 4 is 12. I subtract. I have 3 left over. So I report that as a fraction, my remainder over my divisor. And I get this answer being 3 3/4. So now, if I just take those two numbers, 10 plus 3 3/4, it will give me my total area. And 10 plus 3 is 13, and 3/4 plus 0 is still 3/4. So here I have my final answer, 13 3/4. Here's one I'd like you to try. 2 3/5 times 7. So go ahead and try this one while I pause the video. Okay, so let's take a look at solving it using our graphic organizer. So the first thing I'm going to do is I'm going to put a box up here. And you know what? We'll do this one a little different. I'll just do my graphic organizer as a stacked box this time. Okay, because I can do it by 2 by 1 or 1 by 2. If I do it this way, then the single digit goes where there's a single box. And over here, I'm going to put 2 plus 3/5. Okay, so either way works. And I just need to find the area of each of those boxes and add them together. So the first one's pretty easy, 2 by 7. That gives me an area of 14. Okay, and here again I've got 3/5 for one side and 7 for the other. And I multiply that out. 21 over 5. And this time I'll just put my equivalent right here, my mixed number. So I divide 21 by 5. Well, 5 times 4 is 20. And one more gives me my 21/5. So I've got 21/5 is equal to 4 1/5. To find my final answer, I add those together. 14 plus 4 is 18. And 1/5 plus nothing is 1/5. So my final answer here, 18 1/5. Okay, now let's look at solving one where we have two mixed numbers. And so what I have here is 2.5 times 1 1/3. Okay, and so I'm going to have the 2.5, let's have that go down. So each square is going to represent a half in this instance. So going down, we're representing a half. And starting here, 1/2 1, 1/2 2, 2.5. So I'm going to build my box 5 down. Okay, so go ahead and do that on your grid paper. And then going across, each box is going to represent 1/3. So it takes 1, 2, 3 to make a whole unit, and one more for my third. So I'm going 1, 2, 3, 4 across. Okay, so I've got my box and it's drawn, and in this case over here I have 2, right? 1/2 1, 1/2 2. So I have 2, and I have a second section here that contains my fraction that is equal to 1/2. And going across, it takes 3/3 to make one whole. So there's my one whole. And I've got another section here that equals my fractional part of 1/3. Now if we just look at the diagram to solve this, okay, so I've got an area that is 4 by 5, so that tells me I have 20 boxes, and I also know that I can figure out the area of each unit, each box, by multiplying 1/3 by 1/2, and 1/3 by 1/2 is a 1/6. So each box is 1/6, and I have 20 boxes, so I have 20/6, which 20 divided by 6, well, 3 times 6 is 18, and I have 2 above 18, 2 more than 18, so I have 3 2/6. So that will be my final answer. Let's take a look at solving that a couple different ways. Number one, the other day, we started out just by using improper fractions. So 2.5 as an improper fraction. 2 times 2 is 4, plus 1 is 5, and that's 5 halves. And we multiply that by 3 times 1 is 3, plus 1 is 4, and those are thirds. Multiply that out, and guess what? 20/6. Awesome. Okay, so that's very similar. That's not a lot different than what we did when we had a whole number and a mixed number. Okay, and if that's your method of choice, that's fine, as long as you can come up with the correct answer and then can convert it into a mixed number. But I also want us to look at what if we just took this and divided it like we did the other day, where we divided it into a whole number and a fractional, only this time we've got divided each way. Okay, so here's our problem written out again. I got a little more space to work here now. And what I want to do is I want to do it like we did the problem the other day, where we just divided it out each way. But what's going to happen when we have two mixed numbers, instead of having a whole number across and then just two parts for a whole number and a fraction, now we're going to find out that we're actually going to end up with 4 total parts. Okay, so I'm going to draw this across here, and so that represents our whole number 2. 2 going down, 1/2 1, 1/2 2. So there's our whole number for 2 and another half. And going across, we said we had 1, 1/3, 2/3, 3/3 makes one whole, and we have another third. Okay, so again, we're going to come up, we're looking for an answer. of 20 over 6, which we said was 3 and 2/6, which could be reduced. That 2/6 could also said to be 1/3. Okay, so those are acceptable answers for us. So let's start multiplying. Let's just do each section. So 2 times 1 is 2. And 1/2 times 1 is 1/2. And 2 times 1/3 is 2/3 in this section. And then 1/3 times 1/2, 1/6. So there we have our 4 parts. And again, if we want to know the total area, we have to add all of the parts together. Now, I'm going to do that over here. I'm going to say, okay, here we have 2, and here we have 2/3. Here we have 1/6, and here we have 1/2. The problem with adding this is we need a common denominator. Okay? And we've got 3 different denominators that we're working with. But the nice thing about this method is we're always going to find our greatest common denominator in this corner box right here. Our greatest common denominator that we're going to need is 6. So if we can change each of these fractions into a representation of 6, then we can add them all together and come up with our answer. Okay, so here we have our whole number 2 still, and 2/3. Well, if we're going to combine that, change that into 6, we have to multiply this by 2 over 2. Whenever we multiply a number by 1, it stays the same. Well, 2 over 2 is 1. It's just another way of looking at 1. So when I multiply 2/3 times 1, I get 2/3. When I multiply 2/3 by 2 over 2, I get an equivalent fraction. Okay, so it doesn't change the value because I'm multiplying it by 1. So 2 over 2, 2 times 2 is 4. 3 times 2 is 6. And here we already have one with a denominator of 6. So I can just bring that over. And here I have a half. So I need to make this into a denominator of 6. So I'm going to multiply it by 3. 2 times 3 is 6. And 3 over 3, because I'm multiplying it by a representation equal to 1. And 1 times 3 is 3. And now, if I add all that together, and I've done it correctly, I should come up with something that's going to end me up right here. Okay, so let's add this up. 4, 5, 8. So I have 8 over 6. And I bring my whole number down, it's 2. And again, I've got that improper mixed number, which we can't have, okay? But we know that 8 over 6 is really 1 and 2/6. And so we bring down our 2 plus 1 and 2/6. That gives me a total of 3 and 2/6. And that matches this one right here, and that's one of our choices. Okay, and again, that 3 and 2/6 could be reduced into 3 and 1/3, or we could change it into an improper fraction. 6 times 3 is 18, plus 2 is 20, which would give us this answer right here. So here's another problem we can look at. 4 and 5/6 times 3 and 3/4. And basically, we've gone over 2 ways that you can solve them. One way would be to just change them into improper fractions, and then take those improper fractions, multiply them together to come up with an answer. Or the other way would be to draw a diagram. And you don't have to draw it to scale like I did. You can just draw the 4 boxes and figure out the area inside of each box and add them all together. Okay? But I want you to try one method or the other, see what you come up with, and then we're going to watch the video and see how we did, check our work. So go ahead and do that now. Okay, so the first method that I am going to use to solve this is going to be the improper fraction method. Just change each of these mixed numbers into an improper fraction, multiply them together, and come up with my answer. So here I have 6 times 4 is 24, plus 5 is 29. So one improper fraction is 29 over 6. And the other one, 4 times 3 is 12. 12 plus 3 is 15. And that's 15 over 4. So one reason this method is probably preferred in some cases is it doesn't involve that many steps. One reason it may not be preferred in some instances is because these numbers can get rather large quickly, and sometimes we just like to work with smaller numbers. But I'm going to have to multiply across. Okay, so 29 times 15. 29 times 15, and I like partial products. So again, I'm going to have to do 4 multiplication problems and add all of that together. So 5 times 9, 45. 5 times 2, but that's not a 2, it's actually a 20 because it's a 2 in the tens place. And 5 times 20 is 100. Well, here we have 1 times 9, but that's not a 1, it's a 10 because it's in the tens place. And 10 times 9 is 90. And 1 times 2, but that's not a 1 and a 2, it's a 10 and a 20. And 10 times 20 is 200. Okay, and all that just to come up with my numerator. I have to add all those 4 parts together, and that's kind of helpful because the area model has 4 parts, and this is kind of based on an area model actually. So here we have 5, here we have 13, bring our 1 up here, and here we have 4. So you can see doing this method is going to cause you to deal with some larger numbers. Okay, and along the bottom we have 24. So if we want to know what that is as a mixed number, we would have to divide. And I don't know what your favorite method of division is, but mine is partial quotients. So I'm going to take 435 divided by 24. And in partial quotients, we draw a line down. Let's scoot this up just a little bit in case we need more room. So one group of 24 is 24. 10 groups of 24 is 240. So let's just do that. And I'm going to take out 10 groups of 24, subtract. That's 5. That's 9, and that's 1. 195. Can I get out another 10 groups? No, I cannot. Okay, but I know I can take out 5 groups. Okay, because 5 groups, that's half as many groups. Going to give me half as many. So I'm going to take out another 120, and that's 5 groups. And that leaves me with 5, 7. 75. Well, I know that 3 times 25 is 75. So 3 times 24, if I take out 3 more groups, oops, put the 3 over here. 3 times 4 is 12. That's a 2. And 3 times 2 is 6, plus 1 is 7. So 75 minus 72, that gives me a remainder of 3. So how many groups have I taken out altogether? I've taken out 10, 15, 18 whole groups, and I have 3 left over out of 24. And both 3 and 24 are divisible by 3. So in my simplest form, this is 18 and 1/8. And so that's one method. Okay, so here is the same problem again, only this time I'm going to use my graphic organizer to represent an area model. Again, it's not to scale. We've already shown that the scale model works, so I just need to be able to divide it into its pieces. We'll go with 4 and 5/6 across, and 3 and 3/4 going down. So if I can find the area of each of these individual pieces, add it together, I will have the area of the total piece. Okay, the first one is easy. 3 by 4. 3 by 4 is 12. The next one, 4 by 3/4. So 4 as an improper fraction by 3/4 gives me 12/4. And if you're kind of sharp and catch things when they come up, you can see right away that 12/4, 12 is divisible by 4. So really that's just a whole number of 3. So save myself a little work later, that's what I'm going to do. I'm just going to put my 3 in that box. Okay, this box here, 5/6 by 3. Multiply it out. 15/6. Okay, 6 goes into 15 2 times, and I have 3 left over. So that is 2 and 3/6 as a mixed number, and that just makes it easier to add up, a little less confusing if we can do that. And then the last one is 3/4 by 5/6. 3 times 5 is 15, and 4 times 6 is 24. So in this case, we've already got a proper fraction, and it is 15/24. So now what I need to do is I just need to take and add those pieces together. Piece number 1, 12. Piece number 2, 2 and 3/6. Piece number 3 is 3, and the last piece is 15/24. And notice how I keep things in place value, in a sense, where I've got my fractions in one column and my whole numbers in another. Last thing is, if we're going to add these two together, I need a common denominator. And we talked about how that common denominator always comes from this bottom right box. Okay, so that common denominator is going to be 24. Well, 15/24 is 15/24. Well, I need to make a little room there and let you see it. And over here, 3/6, well, 6 times 4 is equal to 24, so that gives me my common denominator of 24. And if I multiply the bottom by 4, I have to multiply the top by the same number to keep this an equivalent to 1, because really I'm just multiplying 3/6 by 1 to get the same number in a different form. So 3 times 4 is 12. And now I can just add my fractional pieces. 12 plus 15 is 27. My numerator is 27. My denominator is 24. Add up my whole numbers. 12 plus 2 is 14, plus 3 is 17. Okay, and hopefully we've recognized by now that we have an improper fraction inside of our mixed number, so we've got to change that. Okay, so we've got 17 plus, take 24 out of here, give us a whole, and there's 3 more left over. So when we add all that together, 17 plus 1 is 18, and 3/24. And that can also be reduced because 3/24, both of those numbers are divisible by 3. 3 divided by 3, let's do that up here, 18. 3 divided by 3 is 1. 24 divided by 3 is 8. So our final answer is 18 and 3/24, or 18 and 1/8. And if we look at the other problem that we solved, we get the same numbers. We came up with 18 and 3/24, and we simplified it down to 18 and 1/8. Okay, so what we've seen here is that either way we go, we got some work cut out for us. Okay, it's not going to be as easy as it has been. The numbers are getting a little larger, and the steps are getting a little more. So one way or the other, we've either got to deal with larger numbers or more steps, but that's what it's going to take in order to solve this type of problem. So we're going to spend some time working on it, and I want to be around to answer your questions. I want to see those who can do this successfully be able to help others to maybe work on it successfully, because this is part of our standard. This is what we're expected to know in 5th grade, is to be able to multiply numbers that are mixed numbers, or numbers that have a whole number and a fractional component. Okay, so we'll get it. Okay, hang in there.